Using standard error for probability. A probability is a number that reflects the chance or likelihood that a particular event will occur. Probabilities can be expressed as proportions that range from 0 to 1, and they can also be expressed as percentage ranging from 0% to 100%. We can follow the exact sample process for sample means, converting them into z-scores and calculating probabilities. The only difference is that instead of dividing a raw score by the standard deviation, we divided the sample mean by the standard error. So, mo na siya ang formula. Z is equals to the sample mean minus the population mean over the the standard error equals sample mean minus the population mean over the standard deviation divided by the square root of the sample size. So for example, let's say we are drawing samples from a population with a mean of 50 and standard deviation of 10. What is the probability that we get a random sample of size 10 with a mean greater than or equal to 55? That is, for our sample size is equals to n, is equals to 10. What is the probability that the sample mean is greater than or equal to 55? First, we need to convert this sample mean score into a z-score. So, i-convert na to siya into a z-score. Z is equals to 55, which is ang atong 55, mao ni siya ang atong sample mean minus the population mean, which is ang 50, over the standard deviation, 10, divided by the square root of the sample size, 10. So, 55 minus 50 is equals to 5. 10 divided by the square root of 10 is 3.16 is equals to 5 divided by 3.16 equals to 1.58. Now, we need to shade the area under the normal curve corresponding to scores greater than z is equals to 1.58. So, di ba, ang result ganina is 1.58. So, all you have to do is to put or draw a line that correspond 1.58 inside the bell curve. So, makita man natong bell curve, di ba? Kana murag mountain. Mano siya, ang tawag na is bell curve. So, kung mag-base ta sa stem and leaf na table, gimension po siya sa second reporter before. So, now, we go to our z table and find the area to the left of z is equals to 1.58 is 0.9429. Finally, because we need the area to the right per our shaded diagram, we simply subtract this from 1 to get 1.00 minus 0.9429 is equals to 0.0571. So, makita na to siya sa ato ang I mean, nganong 0. Nganong na may 0.9429. So, sa makita na to sa ato ang z table, gipangita na to ang 1.58. Dito sa positive. 1.58. Dito sa 1.5, which is mao ni siya ang ato ang diri sa left mao ni siya ang ato ang stem, ang sa ibabaw naman mao na siya ato ang leaf. So 1.58 plus 0.08 is equals 1.5 plus 0.08 equals 1.58. So kung asa siya magtungod ang 1.5 and then 0.08, nagtungod sila ba? Kung asa sila nagtagbo, mo na siya ang value, which is 0.9429. So, ang ginaingon diri is to find the value of the tail. So, ang atong buhatan is we all know that the bell curve is equals to 1 or 100%. So, in order for us to get the value of the tail, we have to subtract 1 minus the value of the z-score, which is 0.9429. Mao to siya ato nakuha kaganina sa ato ang z-table. Mao na siyang value, which is equals to 0.0571. I-minus nato ang 0.9429 sa 1.00. So, lingawas is 0.051. So, the probability of randomly drawing of a sample of 10 people from population with a mean of 50 and a standard deviation of 10 whose sample mean is 55 or more is P, or the probability is equals to 0.0571 or 5.71. So, anong 5.71 man siya? Kaya nga no, gitime siya sa 100. So, ano siya, 5.71%. Notice that we are talking about means that are 55 or more. That is because, strictly speaking, it is impossible to calculate the probability of the score taking on exactly one value, since the shaded region would just be aligned with no area. Next, now let's do the same thing but assume that instead of only having a sample of 10 people, we took a sample of 50 people first. We find Z. So, instead, sample of 10 people siya, nahimo siya 50. So, katong 10 ka ganina, mauto siya ang first example na to. Karon naman, is ang ato ang instead nga 10 siya, kaganina, di ba, 10, ang atong sample size, karon naman, ang atong sample size is 50. So, Z is equals to 55 minus 50 over 10 divided by the square root of 50 equals 50. Sample mean minus the population mean is equals 5. Dayon, standard deviation divided by the square root of sample size, which is 1.41. So, 5 divided by 1.41 is equals 3.55 or 3.55. Then, we shade the appropriate region of the normal distribution. Next. We run into a similar issue when we try to find Z is equals to 3.55 in our standard normal distribution table. The table only goes up to 3.09 because everything beyond that is almost zero and changes so little that it's not worth printing values. So, ganong magka-problema man, di ba? Kung sa Z table, kung pakita ko na itong 3.55. Kay tungod, ang z-table, as you can see guys, kutob lang jud siya sa 3.0. I-plus nimo siya sa 0.09 is equals 3.09 lang jud siya kutob ang ato ang z-table. So, makamangitaan ng 3.55. So, magka-problema jud ka, diba? So, ang gibuhat, the table only goes up to 3.09 because everything beyond that is almost zero and changes so little that it's not worth printing for values. The closest we can get is subtracting the largest value, 0.9990 from 1 to get 0.001. We know that technically the actual probability is smaller than this, since 3.55 is farther into the tail than 3.09, so we can see that the probability is less than 0.001 or less than 0.1%. So, pag ang sample size n mo taas, ang standard error mo baba. So, ang z-scores mo taas gud siya. Mutaas gid siya, with which the probability value to decrease. Para daw ni siyang gear, turning the first gear, which is the number of samples, sample size, which is ang n. Ang kailan mo gear katong murag kuan sa kadena, makita siya sa kadena nga mo connect, naga-connect gud siya basta nasa sa kadena guys. Makita siya murag. Tapos, the number of sample size daw it will turn into clockwise, which causes the next gear or the standard error to turn counterclockwise, which causes the third gear or the z-scores to turn clockwise, which finally causes the last gear or the probability to turn counterclockwise. So nagatuyok lang siya counterclockwise, clockwise, counterclockwise, clockwise na naman, then counterclockwise. For example, let's look at this one more way. For the same population of sample size 50 and standard deviation 10, what proportion of sample means fall between 47 and 53 if they are sample size 10 and sample size 50? We'll start again with the sample size equals to 10 or n is equals to 10. Converting 47 and 53 into z-scores, we get z is equals to negative 0.95 and z is equals to 0.95 respectively. From our z table, we find that the proportion between these two scores is 0.6578. The process here is left off for the student to practice converting the sample mean to z scores and z to proportion. So 65.78% of sample means of sample size 10 will fall between 47 and 53. So ang ginaingon diri kuhaon ang value sa z scores sa negative 0.95 aning gawas kay 0.1711. So, makita na to siya sa ato ang table. Dili guys. Pangitaon nimo ang negative 0.95. 0.95. Negative. So, kung asa na siya magkatungod guys, mao na siya ang ato ang value. 0.9 plus 0.05. So, aning gawas is 0.1711. Mao gyapon atong buhaton sa ato sa positive nga z-table. So, aning gawas sa negative 0.95 is 0.711 and then kuha ko na ko ang z-scores value sa 0.95 which is aning gawas is 0.8289 tapos i-minus ang 0.1711 and 0.8289 ang result is 0.6578. So mo na siya ang ato ang the student practice convert mo na siya ang value na kuha. So nganong 65.78 man siya kay times man siya sa 100. And then for n or the sample size is equals to 50, our z-scores for 47 and 53 are negative and positive 2.13 which give us a proportion of the area as 0.9668, almost 97%. Shaded region for each of these sampling distribution is displayed in figure 6. The sampling distributions are shown on the original scale rather than as z-scores, so you can see the effect of the shading and how much the body falls into the range, which is marked off with that line. So, mo siya same lang gihapon ang gibuhat sa katong pangitaon ang sa z-table, then i-minus nimo siya, tapos mo to siya ang luwas, which is 0.9668 ang value. And then, times sa 100, mo na 97% ang shaded region for each of the sampling distribution is displayed in the figure 6. Next, the standard error of the mean or simply standard error indicates how different the population mean is likely to be from a sample mean. It tells you how much the sample mean would vary if you were to repeat a study using a new samples from within a single population. Sampling distribution Probability and inferences. We've seen how we can use the standard error to determine the probability based on our normal curve. We can think of the standard error as how much we would naturally expect our statistic, be it a mean or some other statistic, to vary. In our formula for z based on a sample mean, the numerator, the sample size minus the population mean, I mean, sample mean minus the population mean is what we call an observed effect. That is, it is what we observe in our sample mean versus what we expected based on the population from which that the sample mean was calculated. Because the sample mean will naturally move around due to sampling error, our observed effect will also change naturally. In the context of our formula for z, then our standard error is how much we would naturally expect the observed effect to change. Changing by a little is completely normal, but changing by a lot might indicate something is going on. This is the basis of inferential statistic and the logical behind hypothesis testing. That's all. Thank you.